Welcome to the video. Today we are going to solve peak element. In this question we are given an array of length n and we have to return the peak element. Peak element is any element in the array which is the greatest number with respect to its adjacent numbers. For example, see in array 1 the array elements are 1, 2 and 3. Cool, 1, 2 and 3. Okay, and they are increasing in a ascending order. And the largest number, which is 3, is having both its adjacent number smaller to it. But you may say that 3 is having only one adjacent number. Yeah, that is correct. I mean, if out of any number of adjacent numbers which should be there, which are there, all of them should be smaller. So there is only one adjacent element, which is 2 in case of example 1, which is smaller to it. Hence 3 is the peak element. But example 2 will tell you a better definition. See example 2. The array elements are 3, 4 and 2. See the element 4. One of its adjacent is number 3. 3 is smaller to it. Checked. Then again, the next adjacent number 2, is again smaller to it. Hence, 4 is the peak element. So, for any array element, if left and right adjacent numbers are smaller to it, then that number will be peak element. But this can be the first element of the array or the last element of the array too. Cool. And see in the expected time complexity we are given log n, and log n always ring a bell in our head that we have to apply binary search anyhow. Cool. First I will create two variables, low and high, for the low and high range. Okay. Now always low should be less than high. Low should be less than high because so that we are in a defined limit and not index should not escape the limit. Again, I'll create a mid as we do in the binary search. So till here, you will find I'm doing nothing else, nothing new. Okay, and this method of calculating the mid is done so that it does not go out of bound. Index does not go out of bound. Okay. Now first condition: if array mid is greater than array mid plus one. See the mid we have calculated. If the mid is greater than mid plus 1, mid is greater than this current mid is the greatest number. Is if this current mid is the peak element, okay, probably, then we have to go in the left side of the mid. Okay, so this high will become new mid. Sorry, high will be sorry. This this mid will become new high. Okay, so that we will tell ourselves, okay, we have reached a probable maximum peak element, we have reached a probable peak element, and now we have to check on its left side that if all the elements are smaller to it or not, because on the right side we have found, on the right side we have found that this is the smaller greatest number and the right side elements are smaller to it, and now we need to check on the left side. Cool. But if that's not the case, which means the mid number is not greater than the next elements. Okay, so in that case, which means we are still in an increasing ascending format, and now we need to find out in the right side of the array. So this binary search will keep on finding the element, and at the end, it will return out. And as soon as this loop breaks, low becomes equal to or more than high, in that case we'll get our answer and I will return the low element. Let's see how far we have came. Yeah, it does the job pretty effortlessly. As you can see, it took very less time since we are applying binary search, which is order of log n. So I hope you learned a new concept and enjoyed it. Thank you. Have a very nice day.